Okay, so this is going to be the solution to the add two numbers without using the plus or minus operator problem. And to solve this problem, we need to understand what's the computer doing when you actually add two numbers. So if we take a look at the binary representation of an integer, just two examples like this, if you add these together manually, you'll just do like normal addition. 1 plus 0 is 1. 1 plus 0 is 1 again. And then if you have two ones, it's going to be a 0 because we've run out of digits, and then we just need to carry to the left, so we'll get this result. So if we want to add two numbers, we can perform binary bitwise operations, but we need to figure out which or how do we do that. And the answer is there are bitwise binary operators which let us operate on the bits of an integer. And these bitwise operators come in the form of like an AND operator or an OR operator. And an OR operator would be if there are two ones, then if there is any one, then we get a 1 as a result. So like if either one is true, meaning like if either one is 1, then we get a 1 or a true as a result. So to replicate the addition, we can use the XOR function, which means give us a 1 if there is a 1, unless both of them are 1, we'll just get a 0. So you see in these two columns there is a 1, so we get a 1, but in this column both of them are 1, so we get a 0. And you'll notice that this is actually the correct addition, except we're missing the carry bit. Let me just fix that. So how do we get the carry bit? Well, the first step to getting the carry is saying, well, where do we need to carry? Like, where is it actually located? How do we flag it? If we use the AND operator, which is if both are true, then give us a true, or if both are 1, give us a 1, you'll see that the only place that gives us a 1 is this column because both are true. So these two columns are 0, and this one is a 1. So we've successfully identified where the carry bit, or the bit needing to be carried, is. The problem is it's in the wrong position, so how do we move it to the left? Well, there's a thing called a binary left shift. I need to be careful when I'm saying that. Binary left shift operator, and it looks like this. So we can move the bits one place to the left. That's what that means. So if we do the left shifted AND, we will then get 1, 0, 0, 0, and we fill in the right hand side with zeros. So now that we have the carry bit, which is the left shifted AND, so we have the carry in the correct position, and we also have the initial correct addition but without carries, we just need to add these two things together. So if we do 0, 1, 1 plus the carry portion, this will give us the correct answer. So to summarize the basic steps, what we need to do is we need to take A and B, we need to find the XOR, or the addition, and we also need to find the carry. And then we need to add those two things together. But the problem is, what if once we've added these together, so let's say the XOR gives us this, and the carry gives us this. The problem is, we have another carry here, so we need to repeatedly check for carries. So what we do once we've added these two things together, this might be us finished, but it might not be. We have to check, is there another carry from the result of this operation? And if there is, we just do the same thing again. And we repeat that until the carry becomes 0. Because there's nothing left to carry. And let's say there is nothing left here, then the answer is just going to become the result of the XOR plus that carry. And then nothing else. We stop. So in the code, let's define a variable to hold the carry, and let's define a variable to hold the result of the XOR operation. We'll set the carry to be B, or the right hand side of the operation initially, and then we will say while the carry is not 0, we're going to loop through. And the reason we do that is because, remember, we might have to keep carrying, so we're in a loop to figure out, or to finish off the carrying. And the reason we say while the carry isn't 0 is because if we have a 32-bit integer, so we can store 32 bits, if there's a carry here, and let's say in theory it's going to show up to the left every time, we need to keep doing the carries until there are no ones. And there will be no ones once we have moved all the ones out of the range of the integer. And then we'll only be left with zeros, because remember the carry just fills in zeros from the right. So what we can do here at the end of the function then is just return a, because let's say the carry is always 0, or rather the b, the second half, is 0. Let's say it's int a is 10 and int b is 0. That means there's never a right hand side of the operation, and 10 plus 0 is 0, so we can just return a as return the answer. Okay, so what we need to do here is find these two pieces of information, the XOR and the carry. So the addition, we need to find the XOR, so we use this operator. It is if you press Shift 6 on your keyboard, and then we say with carry. So this is the XOR operator. So we're finding this, and then next we need to find the carry. So we say carry is equal to a and carry, but then we left shift it. That's the two side brackets there by one place. So now we have found the XOR and we found the carry, and we then need to add them together, and we know that the XOR does add correctly, so we can use that again. So we can say a for answer equals addition XOR carry. So we now have the result, but may need to carry further. So what we do is the same as above. We do this step. Do we have a carry? We need to figure that out. We can say carry equal to so we do the same as this. So like whenever we were finding a, we just take those two variables, but we change the bitwise operator the same way. So on the left here, we found XOR by doing a and b, but with the XOR operation. And then we find the carry. We use a and b again, but we use the AND operation, and then we left shift it. So we do addition and carry to get the and then we left shift it by 1. And if this, so we now know if XOR plus carry has another carry. So if carry is now 0, this while loop isn't going to continue. So say it were like the first example where we had, it was something like 0, 1, 1 and 1, 0, 1, 1. Once we join these numbers here, or I think that's, let's say those are zeros. Once we join these numbers together, which is this step here, there will be nothing further to do because there's no more carries. Because if we did an AND operation on these two numbers, you'll see that the AND returns false. So like none of this is going to show up, and the carry is going to be equal to 0. So the while loop stops, and then it just returns these two numbers added together, which is going to be here. So if we run this code, we should see that it works. Hopefully I've done no typos. Okay, there we go. And the submission should work as well. Yep, there we go. So that's it working. I hope that helps. I hope it makes sense. Thanks.